Hi all. So as you know, PyAEDT enables the automation of all the electronic desktop tools like HFSS, Maxwell, IcePack. So it was difficult to just find one single advanced workflow, but we choose this one, the virtual compliance, because it's an advanced post-processing workflow that it can be used for any other tool. So let's start. So what is virtual compliance first, just in case you are not aware of this virtual compliance? So first, it's a methodology for testing and verifying high-speed interfaces. So it has many advantages and benefits because you can early detect issues, you can reduce the cost of your designs, and it's a faster time to market cycle in your device cycle. So basically, it reduces the number of iterations and physical hardware testing that you need to do for creating your designs. So why we should use PyAEDT for this kind of application? First, because using ADT provides a detailed and accurate electromagnetic solution. So we could use HFSS, SA wave, circuit, but again, you could use any other kind of electronic desktop application like IcePack if you need some requirements from thermal electronics. And then PyAEDT provides the flexible scripting tool to validate the different metrics like signal integrity metrics, power integrity, interference, so different kind of stuff that the standard could require. Why PyAEDT it's needed here? Because we could use some advanced post-processing tools like NumPy, Matplotlib that will allow us to quickly detect some pass-fail criteria. Also, we could create, as I will show you later, the PDF that could be like the final report where the designer could find the different checks of the standard. So we created in PyAEDT a class that is called virtual compliance. That is a set of configuration files that the user could modify to define different standards. So we created one that is the PCI Express one, but again, you could create your own one like DDR, Ethernet, whatever you need to pass. And then very easily and repetitive, you will be able to create this virtual compliance. So let me show it to you how it works. So as I said, it is based in configuration files. We will define like a main JSON file that will contain all the information of the standard, like what I need, like insertion losses, I need eye diagrams, different kind of stuff. And then each section of the standard will contain some mask and some information to validate the pass-fail criteria. So that's the only thing that we need to modify per every virtual compliance standard, and that's all. So how it works, very easily, I will show you a demo later, but it's we just need to open the electronic desktop using PyAEDT, and then we will initialize the virtual compliance class, and then we could, once we initialize the virtual compliance, we could modify the information of the template. Again, the template that we have defined is the PCI Express generation 5. And then you could just modify the different expressions depending on the name of your pins or traces of your layout. And that's all. Once you have everything, you could just call this create compliance report. And finally, we will have a PDF with all the information. And let me show it to you now in a quick demo how it works. So basically the PDF, the final PDF will be something like that. So you can think that we could create like a user interface in top of that, where the user could choose different kind of stuff that we need for our virtual compliance. And finally, you will get this report. So then the final user could even don't know that they are using Ansys for the simulations, but they will get this virtual compliance that the designers needs to know if their designs pass or not pass the standards. So how it works in a nutshell. So imagine that we have this PCB, this one, for example, that is a PCI Express channel. So then with PyAEDT, this is not part of the virtual compliance, but with PyAEDT, we could create quickly, if we needed, some circuit stuff. Okay, as you can see here, first I'm creating a frequency simulation. As you can see here, it's called an LNA. So I created the first one, then we could create different stuff. So let me go ahead. So with PyAEDT, you could even create the automation part of these designs. This could come also, it can be created manually, all this stuff, but again, we prefer also create this by scripting because then it's automatic. And then we'll have our project. Our project is our main layout and different circuits that are defining what I need for the virtual compliance, like the TDR analysis or the IV's AMI analysis. Once I have it, I will load the virtual compliance. As I said, we initialize the virtual compliance class, and then I'm modifying the defaults. Like, okay, for the insertion losses, I'm asking the virtual compliance to look to the LNA circuit design, this one. For the TDR design. So far, so we can go ahead. And finally, we will create the virtual compliance. So if we go ahead, you will see that now it's going to retrieve all the data from the different circuit. So now it's going to start all this stuff. If I'm not wrong, yeah, it's getting all this information now. So in a second, we will see how it's going to start the reporting part, as you can see here. So again, everything is defined in the JSON file. So in the meanwhile it's creating, let me show to you how it looks like the main JSON file. So here is the main one, the PCI Express, where we define the project name, for example, or in the reports, the different stuff that we need, like the insertion losses. So the design name by default is circuit 1, but what we modify here in the script is that instead of circuit 1, we call it LNA in our design. So this is what the user has to change from the template. So the name of the design name or the expressions, because every design will have a different name for the different traces. But once you have this, you will have it forever. And then you will, your company could create their own virtual compliance test. And here we have also the mask. That is where we define the limit lines that will define the pass-fail criteria. So now it finished. So as you can see, it is closed, the electronic desktop. So if I go to the folder where everything is saved, we can go to the PCI project. So this is the project that we just solved, this project AQA. If I go inside the PyAEDT, we could see that it created all the different plots. Okay, in an spreadsheet, we have all the information, but also we created the PDF that contains all the information in a better way. So finally, the designer could check. So here we could add also some pictures from the standard. So this is just static pictures. But what is interesting is, as you can see here, you have all the criteria where we could find if it pass or not pass our limit line. In this case, this yellow line is the pass-fail criteria, but there are some cases, if I'm not wrong, that they don't pass, as you can see here. So then in the table, you will see which one are not passing, and then the designer could decide to change some of the rules or some of the traces for improving this zone 3 of our PCB for passing the standard. So as you can see, just with a few clicks, we are able to create our own virtual compliance using the accurate simulations of Ansys, of HFSS or SA Wave. So basically that's all what I wanted to show.
Thank you, Samuel. Julia, PyAEDT Extension Manager.
Yeah, thank you. Let me share the screen. Okay, this is the screen?
Yes.
Okay. Okay, so thank you. So in this short session, I'd like to show you the capabilities of the Extension Manager, which is accessible within Ansys Electronic Desktop. If you remember, in the first session, we saw how to install PyAEDT and the ribbon bar within ADT. So today I won't cover this part, and if you want to refresh your mind about the procedure to follow, you can have a look at the shared presentation, or you can visit the PyAEDT page, the installation section, and you will find all the information that you need. So let's start with the extension manager. As you can see at the top right side of the slide, after you successfully install PyAEDT, you can access the extension manager within ADT, where you will find the newly created ribbon bar accessible through the automation tab. I will show you later how this looks like. So the extension manager allows you to add extensions with a few clicks. But what do we really mean with the extensions? I think it's better to clarify this concept before. So there are three types of extensions that you can install thanks to the extension manager. First of all, you can install custom extensions, then pre-installed extensions, or open source toolkits. You will hear that they can be installed both at the project level or at application level. But what do we really mean by that? So extensions that can be installed at project level are not application specific. So for example, if you remember in the second session, so last session, the ADT field calculator is not application specific, which means that it is installable and accessible for all types of ADT applications. Whereas when we say that it's available at application level, it means that the extension is application specific and can only be installed and accessed in a specific application. You will see later, I'm going to show you the open source toolkits. These are examples of application specific extensions because you can install and access them within a specific application. Okay, so now let's see in the following slides what are these three types of extensions. So first of all, custom extensions, they are custom workflows that can be installed both at project and application level. They are none other than Python scripts that can be accessed with a simple click in ADT. If you want to install your custom workflow within ADT, you simply need to add a common section at the beginning of your script to define the port and the version of the ADT session that you want to connect to. Again, I will show you at the end how to install this type of extensions and where to add this common section in your Python script. Then we have the so-called pre-install extensions. They are small automated workflow with a simple UI, again, as it is for the advanced field calculator. They are available, they are a project developed by us that can be accessed both at project and application level. You can see here I copied the link that redirects you to the PyAEDT documentation page where you will be able to see the list of available pre-installed extension. And then finally, we have the so-called open source toolkits. They are more complex workflows with a complex backend and UI that can be accessed only at application level. They are application specific because they tackle an application-specific matter. So these are open source projects which are accessible via GitHub at the links that I provided here in the slide. And as you can see for now, we have two of them. One is accessible through HFSS for antenna design, and one is accessible through Maxwell 3D for skew and segmentation of electric motors. We built them by leveraging a framework that we created that is called PyAEDT Common Toolkit that provides common methods and best practices for creating ADT toolkit. Again, I will show you later how to access them within ADT and how the UI looks like. So now let me show it to you, the extension manager. Do you still see my screen? Do you see ADT? Okay, I guess so. So this is the ribbon bar that you should have after successfully install PyAEDT. And then here you can open the extension manager. So this is the extension manager, how it looks like. And as you can see here, you can decide whether you want to install for example, your custom workflow at project or at application level. Here you have all the applications, all the ADT applications available. Regarding the pre-installed extensions, for example, we have some of them at project level. In fact, if you open here, if you click here, you have the list of the already available pre-installed extension. For example, as it is for the fields calculator. You can select one of them if you want to install, and then you click install. Now, I won't install the fields calculator because, as you can see here, it's already installed in my ADT environment. The other option is custom extensions, if you remember. So, for example, I prepared a very simple demo for you. So this is my my script. And as you can see, basically my workflow is very simple. It just consists of creating a sphere, but it's very important for you because it has the common section that I was speaking about, where it can automatically detect the script port or the version, the ADT port or the ADT version of the ADT session you would like to attach. Or otherwise, if you don't have this environment variable, this default value will be taken. And then here you have your workflow. That in my case, it's very simple again. Now, what you have to do is to copy the path as the absolute path of your script and provide it to the extension manager. For example, I clicked here on the project because I want my no, let's do it for Maxwell 3D. I click on Maxwell 3D because I want my workflow to be accessible within Maxwell 3D. So here I click Custom, I paste the path of my Python script, and I don't know, I call it test, and I install it. Now the installation starts. Now to see if the extension is now available, I open a new project. If you remember, I install it at application level, a Maxwell 3D application. So I open a Maxwell 3D. I go to Automation tab, and you can see that now my workflow is accessible with a simple click within ADT. If I click here, if you remember, my workflow just consists of creating a sphere. Here I have some PyAEDT information. The sphere is created. Okay, you see, this is my workflow, and as you can see, it's very useful. It's very convenient because you can access your workflow just with a simple script. And also another thing is that you can also uninstall your extension, your custom extensions, if you don't want them anymore. As you remember, the third option are open source toolkits. Now, we can take as an example the Maxwell 3D one, which is it's the so-called magnet segmentation wizard toolkit. Again, I don't click install because it's here already for me. So if I click on it, you see that a window is opening, and in a second you will see the toolkit coming up. It takes a couple of seconds, and you will be able to see the UI of the toolkit. Okay, so here you have it. These are our open source toolkits. The antenna wizard has a similar UI because, as I mentioned, we have a common framework that gives us the basis to build on top of it, like our custom toolkits. In my case, you see we have some predefined section, a project where you can select the project that you would like to perform the segmentation and skew. You see, it automatically detects the project and the design. And then in this specific case, which is oriented on electric motors, I need some information such as the materials. And then here I can provide some other information. You see also for materials, everything is automatically detected. Here we have some buttons to perform the segmentation and skew. And then we have some post-processing part. Also, we have a logger that logs everything that the toolkit is doing. Again, it's very customizable depending on your needs. Okay, so that's it on my side.